Gas-related hazards can be grouped as follows: fire and explosions, asphyxiation, poisoning and chemical burning. Before we explain these hazards, we need to discuss an important fact concerning gases. We must be aware that different types of gases have different densities, or mass. In other words, some gases are lighter than air, whilst others are heavier than air. Any gas that is heavier than air, in the event of a leak, tends to sink and settle in the lower regions of a confined space. Gases that are lighter than air tend to drift upward and collect in the upper regions of the space. Fires and explosions are risks that are generally associated with flammable and with oxidizing gas types. A leak of a flammable gas into a confined or poorly ventilated space will quickly create a highly flammable or even an explosive atmosphere within that space. To demonstrate this, we shall perform an experiment using the flammable gas LPG, often referred to as liquid petroleum gas or liquid propane gas. LPG is a heavier-than-air gas. To begin, we shall demonstrate that no flammable substances are present within the containers that we shall be using. Next, we allow some LP gas to flow into the bottle, and because it is a heavy gas, we can expect it to displace the air within the bottle and remain inside. The next step may appear ridiculous, as nothing seems to be coming out of the bottle. But that's the problem with gas. You can't see when it's creating a hazardous atmosphere. This simple experiment proves two things. Firstly, that LPG is heavier than air, as is obvious because we were able to pour it from one container to another. And secondly, that a flammable gas such as LPG, even in small concentrations, creates a highly flammable atmosphere. Any leaking flammable gas, depending on the density of that gas, will collect at varying levels within a space and create a flammable or explosive atmosphere that may easily be ignited by even a tiny spark. We often mistakenly assume that the oxidizing gas oxygen is a safe gas because it occurs in the air that we breathe. Air is made up of a mixture of gases that includes oxygen. However, compressed oxygen in a cylinder is virtually pure oxygen and affects combustion differently from air, as we shall demonstrate. We begin by putting a little oxygen into a bottle. It will remain in the bottle because it is slightly heavier than air. Next, we ignite some wood and get it burning. We then blow out the flame to leave a glowing ember. Now, watch the reaction when it is placed into the bottle containing oxygen. This experiment proves that air and oxygen are different, and illustrates why oxygen can be regarded as being a serious fire hazard. Under certain conditions, oxygen can present an almost explosive situation. An oxygen leak within a confined space will quickly raise the oxygen concentration of the air within the space to a level above normal 21%, and this is regarded as being an oxygen-enriched environment. To demonstrate what can happen within an oxygen-enriched atmosphere, we shall perform a simple experiment by placing some cotton wool into a jar and then saturating it with pure oxygen. Watch what happens when the burning cotton wool on the outside of the jar reaches the oxygen-enriched atmosphere within the jar. The result, as can be seen in this slowed-down replay, is virtually explosive. A particularly hazardous practice is that of using oxygen from the gas welding set to dust yourself down. Clothing and body hair, if enriched with oxygen, will ignite easily and burn readily. Both flammable and oxidizing gases pose a very real and serious hazard of fire and even explosion under certain conditions. The next gas-related hazard, and one often overlooked, is that of asphyxiation, which means being deprived of oxygen, the gas we depend on for our survival. Gases such as argon and carbon dioxide are heavier than air. When used in a poorly ventilated or confined space, a heavy gas will accumulate in the bottom of the space and displace the normal breathable air within that space, resulting in an atmosphere that is oxygen deficient. To demonstrate this effect, we shall again use a candle in a jar. The jar is open to the atmosphere and the candle is burning normally. Next, we introduce argon into the jar. Watch what happens. Due to the fact that argon, being heavier than air, sinks to the bottom of the jar. As the level of argon rises, it displaces more and more air in the jar. At this point, there is insufficient oxygen to sustain combustion or life. A major problem with any neutral gas is that you cannot smell it, see it, or taste it. Asphyxiation can occur very suddenly without a person being aware of the problem until it is too late. The hazards associated with toxic gases and corrosive gases really speak for themselves. A toxic gas, if ingested, inhaled, or in some instances even when absorbed through the skin, will poison you. Corrosive gases, if inhaled, tend to react with the moisture within your body, producing strong acids or alkali. These substances chemically burn away the soft tissue within your respiratory system. This damage is usually severe, extremely painful, and often results in death. When working in areas that utilize toxic or corrosive gases, special safety regulations must be strictly adhered to, as well as the wearing of special personal protective equipment. An awareness of the potential hazards involved in the use of different gases is the first step in making sure that neither you nor your colleagues are the cause nor the victims of gas-related accidents. Detailed safety information, plus other information on any particular gas type, is available from material safety data sheets supplied on request from your gas dealer. This concludes the video presentation for the Gas Hazard Awareness module. You can learn more about gas safety and related issues by participating in other modules in the Gas Safety series.